So here's a common mistake made by kids, and not just algebra, algebra 1, algebra 2, but clear up into my pre-calc classes. So let's look at it and see why this happens. I think one of the reasons why this happens is this minus sign does not allow us to distribute this exponent. We cannot apply this exponent to each variable like this. All right, and one way to combat this or show that this is false is just pick some numbers. Let's suppose we let a equal, I don't know, 7 and b equals 3. So substitute 7 and 3 into each of these expressions. So 7 minus 3, that quantity squared, is it equal to 7 squared minus 3 squared? Well, let's go through this. So, following order of operations, we would subtract 7 minus 3 first, and that would give us a 4, and 4 squared is 16. So let's see, is it looking like it's equal to 49, right? 7 squared is 49 minus 3 squared, which is 9. Hey, wait a minute here. 49 minus 9 is 40. So 16 does not equal 40. So just sometimes if you're not certain of something, students just need to pick a number and substitute it in place of the given variables. So when you see a minus b, the quantity squared, like we have it right here, a minus b, this whole quantity is being squared. What this really means is a minus b times a minus b. So again, let's, like the previous slide, let's look at when a is 7 and b was 3. So 7 minus 3 quantity squared equals 7 minus 3 times 7 minus 3. So that's the same as saying 4 squared is equal to 4 times 4. So that is how that works. I think on the next slide I'll show you how this is getting confused. So a squared minus b squared really falls into a special factoring formula where we say the product, or I'm sorry, we say the difference of two perfect squares is equal to the product of the sum and difference of two numbers. And those two numbers are the square roots of these two numbers. So that would be a plus b times a minus b. So notice from the previous slide, this is not equal to a minus b times a minus b. So that's what accounts for this difference. So what you have to be careful of is what sign is in here. If this were a multiplication sign, then you can apply exponents to every factor inside. But it's not. This is not a multiplication sign. So a quick example would be, let's suppose I have, we'll keep it simple, a squared minus 25. And the instructions would say, oh, factor this. We'd say, well, that's the product of the sum and difference of two numbers. So the product of the sum and difference of two numbers, the numbers being a squared and 25. Well, 25 is a perfect square, so we recognize this as a squared minus 5 squared. And then we say, aha, that fits this pattern up here of a plus 5 times a minus 5. And again, the way you could check this is just to pick a number to put in place of the a right here. So let's say a is 7, because 7 is my favorite number. If a were 7, you'd have 7 squared minus 25, which is equal to, scooch that over a little, 49 minus 25, which is equal to 24. All right, now pick that same number and put it in place of our expression over here. What is 7 plus 5 times 7 minus 5? Okay, simplify this, 12 times, simplify this, 2. Hey, 12 times 2 is indeed 24, the same as what we got up here. So hopefully this will help you straighten out what we saw back on the first slide, which was this. These two expressions are not equivalent. All right, hopefully this was helpful to you. If you liked it, please go ahead and give us a like.